Look closely. What do you see? A shard of pure, impossible color. It seems to glow from within, a fragment of light captured in solid form. This is not glass. It is not something made by human hands. This is a treasure born of the earth itself. It is a spectacle of mineral beauty that can stop you in your tracks. To see a fine crystal of Elbaite is to witness something extraordinary. It is a silent explosion of color, a quiet testament to the immense and patient artistry of our planet. So what is this remarkable substance? What is the identity of this painterly stone? Its name is Elbaite, and Elbaite belongs to a large and famous family of minerals known as the tourmalines. The tourmaline group is renowned throughout the world for its complexity and its astonishing range of colors. But among all its members, Elbaite is perhaps the most celebrated of all. It is the species that produces the most vibrant, the most varied, the most sought-after hues that make the tourmaline family so famous. It is, in essence, the artist of the family, responsible for its most spectacular works. Put simply, Elbaite is a silicate mineral. This means its fundamental structure is built from silicon, oxygen, the two most abundant elements in the Earth's crust. But its full chemical name is a complex tongue twister: sodium, lithium, aluminum, borosilicate. That complicated recipe is the key to its magic. The presence of elements like lithium is what sets Elbaite apart from its other tourmaline relatives. The range of colors found in Elbaite is almost without limit. It is a true chameleon of the mineral kingdom. Let us begin with the greens. You can find Elbaite in a soft, minty green, as delicate as a new spring leaf. Deeper, more commanding greens, the color of ancient moss on a forest floor. A bright, zesty lime green, full of energy and life. A dark, bluish-green tone that speaks of the deep sea. Each shade of green tells a slightly different story, a subtle variation in the chemistry of its birth, creating an entire ecosystem of color within a single mineral species. Then there are the pinks and reds, a pale, almost ethereal pink, like a blush captured in stone. A vibrant hot pink, a shocking splash of magenta, a profound luxurious red, once mistaken for ruby. This red variety is called rubellite. Blue is one of the rarest and most prized Elbaite colors. Trade name, indicolite. Light, sky blue. Deep, inky indigo that verges on black. The most desirable blues have pure, intense saturation, like a fine sapphire. The secret to Elbaite's rainbow lies in chemistry, a chemistry so subtle it feels like alchemy. As we have seen, the basic Elbaite crystal is colorless. The color we see is the result of light interacting with tiny amounts of metallic elements that have been incorporated into the crystal lattice as it grew. Different elements absorb different wavelengths. The color we perceive is the light that is left over, the light that is reflected back to our eye. It is a subtractive process, a delicate dance atoms, photons. The most common color-causing agent in Elbaite is manganese. Even a tiny trace of manganese atoms can be enough to produce the beautiful pinks and reds. As the concentration of manganese increases, the color deepens: pale rose, bubblegum pink, rubellite red. It is a simple sliding scale, where a few more atoms per million can completely transform the appearance of the final gemstone. Iron, on the other hand, is responsible for a different part of the palette. Depending on its atomic state and its position within the crystal, iron can produce a stunning variety of greens, blues. Iron is also the key ingredient for the blue indicolite varieties. Often, both iron and manganese are present in the same crystal. Their interplay can produce interesting secondary colors, brownish tints, purplish tints, adding yet another layer of complexity and nuance to Elbaite's incredible spectrum. Among the endless combinations of color, certain patterns are so distinctive and so beloved, they have earned their own special names. They are nature's masterpieces, celebrated by collectors, celebrated by designers alike. Perhaps the most famous and whimsical of these is the watermelon tourmaline. This is a crystal that typically has a pink core or a red core surrounded by a distinct rind of green. When a slice is cut perpendicular to its main axis, the resemblance to a slice of the fruit is uncanny and delightful. It is a perfect, joyful accident of geology, a reminder that nature has a playful side. Another highly sought-after variety is the bicolor Elbaite. While watermelon tourmaline is a specific type of color zoning from the inside out, bicolor simply refers to any crystal that displays two distinct and well-defined colors. The transition between the two can be sharp and abrupt, or it can be a gentle, blended zone. A classic example might be a long, pencil-like crystal that is a vibrant green for half its length, and a brilliant pink for the other half. Then there are the varieties known for a single, exceptional color. We have already met rubellite. Its blue counterpart is indicolite. These names are not separate mineral species. They are trade terms, poetic labels used to describe the very best expressions of a particular hue, recognizing those rare specimens that achieve a perfect, uniform shade. Finally, a truly phenomenal and rare variety is known as lydicoatite. When sliced, these crystals can reveal intricate geometric patterns, triangles within triangles in a kaleidoscope of colors. They look like abstract art, but they are a completely natural record of the crystal's growth history. These special varieties demonstrate the sheer artistic range of the tourmaline family. They are not just minerals, they are unique, individual sculptures crafted by the earth over geological time. These crystalline treasures are not found just anywhere. Elbaite has a very specific birthplace, a type of igneous rock formation known as a pegmatite. Pegmatites are formed during the final stages of magma crystallization. As the main body of magma cools and solidifies, it leaves behind a residual fluid that is rich in water, rare elements like lithium, boron, and other volatile components. Because it cools very slowly, it allows for the growth of exceptionally large and often very pure crystals, creating a perfect nursery for gems like Elbaite. These pegmatite dikes are found in specific geological regions around the world. Historically and to this day, Brazil is arguably the most important source of fine Elbaite. The state of Minas Gerais has produced a staggering quantity and quality of Elbaite in every conceivable color. But Brazil is not alone. In recent decades, other locations have emerged as world-class producers: Afghanistan and Pakistan, Madagascar, Nigeria, Mozambique, and Namibia. Mining is often done on a small scale, sometimes by hand, with miners carefully following the pegmatite veins through hard rock. It requires great skill, patience, and a bit of luck to locate a pocket of pristine crystals without damaging them. Once unearthed, these rough crystals are sold to gem cutters, who study each piece to decide how to best unlock its inner beauty. The cutter's art is to maximize the stone's color and brilliance while preserving as much of its precious weight as possible, finally revealing the fire that has been hidden for an eternity.